Hello everyone. In this tutorial, we're going to extend one of the previous tutorials where we looked at how we can do some very initial data exploration in R. This tutorial is divided into three basic parts. So we're going to start with how we can check quantiles from a numeric of a numeric column from a dataset. And then we're going to look at how we can check how many unique values or unique labels that we have in a factor data column. And then we're going to look at how we can create cross tabulation in R. And in doing so, we're going to look at how we can create the cross tabulation based on count, absolute count, and also based on proportion or percentage of unique values. So first of all, we're going to load the dataset. The dataset that we're going to use in this tutorial is called Star Wars. So that dataset comes from library dplyr. So first of all, I'm going to load the library dplyr, and then I'm going to load the dataset. So before we jump into the tutorial, we can look at the dataset and see what it contains and how it is containing the data. So what this dataset contains is basically it holds data about all the characters in a Star Wars movie series, and it has data in different attributes about each character. So we can see Luke Skywalker, his height is 172, body mass is 77, hair color blonde, and so on. So one good thing about this dataset is that it contains different kinds of data types in different columns. So here we can see the height is 172, 167, and seems like it contains very basic integer kind of numeric data. Second column mass, it looks like it has fractions in it, so which mean that it has double data type, which is also a kind of a numeric data type. And hair color is blonde, none, and brown, so which is basically, it seems like it's going to be a certain limited number of colors in there, which in R's language is called factor, and so on. And if we go down further, we can see in these columns, films, vehicles, and starships, they don't look very regular type. So in films, what we see, if you just hover over, we can see this. There's a window that pops up and it shows what that cell contains. So what it seems is that each cell, it doesn't contain just one value, rather a list of values. So in this tutorial, we're not going to address these issues, that how we can extract values or make these columns more useful. We're going to, in one of the future tutorials, I'm going to show you how we can deal with that kind of data too. So in this tutorial, we're not going to focus on these three columns, which has multiple values in one cell. We're going to leave that. We're going to mostly concentrate on one of those two columns, which has either numeric values or some limited number of unique labels. And also another really great thing about this dataset is that it contains a lot of NA values. So in any kind of real life data, you can expect to have different kinds of NA values. Here, this dataset gives us kind of a very intro level exposure to dealing with NA values, and we're going to see how we can exclude those NA values and run our regular stats on the data. Okay, so to start off, the first thing that we're going to do, we're going to check how we can produce some quantiles from a numeric column of the dataset. So to do that, I'm going to start with our very known function called summary. So summary function, in previous tutorial, I showed you how we can use summary function to look at the summary view of each of the columns in the entire dataset. So we're going to do the same thing here. So if I run that code, immediately we can see that the output doesn't look like regular output. It's because the last three columns, which contains multiple values in each cell. So if you go up, we can see these other columns, they have some sort of regular view that we are used to when we deal with regular dataset. So if you go back to height, we can see that it produces mean, first quantile, median, mean, third quantile, and max and whatnot. So this is one way that you can get to know that how the data is distributed from each of those if you look at individual column. But one thing is that may make it really quite not so comfortable experience is if you have, let's say, 200 columns, then it's not a good job. It's going to be a hectic job to look at individual columns in that way. So to do that, what you can do, you can look at individual column, which is your interest. So here we are interested in height data, and we can mention that here like this. So in R, the basic notation is if you write down the name of the dataset and you follow that by $, and then you can mention the specific column name to look at data from only that one specific column. So if we use that column data as an input inside the summary function, run that function, we can see it shows us only summary data about that one column. One additional thing that we're going to show today is how we can extract, let's say, when you run this function, it gives us a list of values, mean, max, and all the other quantiles. So let's say I'm interested to look at the third quartile values. So here we can see it's 1, 2, 3, 4. To check on the fifth element, we can mention 5 inside the inside brackets, and we can run the command, and we can see the third quartile is 191. And what is more useful is that you can use that as part of any function. So let's say I want to multiply that number, that third quartile, by 2, and I can run this function, and we can immediately see it multiplied 191 by 2. So this is one way to see individual columns, quantiles, and to look at individual value from that summary output. We can also use another function which is called quantile, and which is more intuitive. So how the quantile function works is basically it's pretty much the same. So it takes okay, let's Star Wars. Damn. Yeah, so it takes the input value in it, and then you need to give it the probabilities based on which it's gonna break the data down. So let's say we are interested into looking at quartiles. So we're gonna break the entire data into 4 equal parts. So to do that, we need to give it the breaking points, right? So we're gonna break 0 to 1 into 4 different parts. Each will be 0.25 points apart. And then we need to add one more function, which is called na.rm, one more argument. So na.rm is basically, it's a pretty common argument in most of the R functions. So what it does, it tells the function to avoid the na values. So if you have na values in your data, make sure that you include that na.rm is equal to true. The default is usually false, which means the function shouldn't care about na values. It should include the na values. So when you exclude na values and run this function, you can see it immediately produces the same results here as we have seen from the summary function. The only difference is formatting. So in summary function, the output was formatted as double numeric values, and here it's formatted as integer numeric values. But they're equal, like essentially the same values here. And like you saw in the summary function, we can get individual elements of that from that list. So if I want to look at, let's say it is 75th, so which is going to be the third quartile values. So we're going to look at this is here, the fourth element. I can look at the fourth element. It's showing me 191. And also, as we have seen earlier, we can multiply that. We can use it as part of an equation. So let's say rather than multiplying, I'm going to divide it by 2. Run that. So now I see it is dividing 191 by 2. Also, we can save these values. So the object, let's call it height quartiles. And we are saving these values here. So right now, if I want to look at what is in height quartiles, I can print it out and we can see it here. And secondly, now we are going to look at how we can look at what are the unique labels that a factor variable contains in our dataset. So to do that, I'm going to look at the home world column. So if we want to look at here, home world, here, this is the home world. So we can see it has values like Naboo, Tatooine, and Aldernon. So we're going to look at how many unique names are there in the home world column. So to do that, it's really a useful function to give you a better idea that what is inside your dataset. So if we just need to provide in unique the name of the column, the data, specific data from a specific column, and then it's going to produce the unique labels that it sees inside that column. And now we can see there are a total of 49 unique names, which is a lot because we have only 87 observations. So on average, it's like about less than 2 observations for each unique name. Anyways, so that's how we look into the unique data set. And also it's to become more user-friendly, you need to do is we can actually sort these values descending or ascending order. So I'm using piping here, so which comes from dplyr, and I can use a function from base R, which is called sort. So what it does, it sorts in increasing order. So it's starting from A, ending in Z, and then you can change it to decreasing true, and then it does the opposite. So that's pretty much it, how we can look at unique values of a column. And also there is an alternate, I'm going to show you another alternative function to do that. And the function is called labels. So in R's language, label mean each factor name. So let's say you have a factor data in a column, and each factor name is called labels in R. So the label function is what it does basically. So I'm not sure if that data is, if these names are stored as a factor or stored as a string, like just a text. So we need to make sure that inside label functions, the data values are stored as factor. So that's why I'm using this factor function. And what it does basically, if you provide a string inside factor function, is going to convert that as a factor. So here now I'm going to provide it with data. And now if I run that code, it produces the same result. And the good thing about using label function is that it sorts the output automatically. You don't need to mention anything. And also you can use this sort function if you want to change that the sorting order. So if you want to sort the sorting, the label function, it already sorts the function in a ascending order. If you want to make it descending order, you can just use the sort function. It works exactly the same way as it did with the other function, unique function. So the last section in this tutorial, we're going to talk about how we can do cross tabulation. So cross tabulation means when you want to look at two different or multiple columns in combination to each other and see different combinations of these columns, how many observations they hold or stuff like that. So the way we do that is another really simple function is called table. So the table function, it takes, so let's look at with just one variable. So let's say we want to look at the species and we give it, and what it does basically, it takes out the species and it counts how many times each species appeared in the dataset. So we see the human species has the most number of observations in the dataset, which is 35. Every other species is really low in their frequencies. And also we can use this table to look at combination of two different columns. So let's say we're going to use, we're going to look at species in combination with gender. And then if you run that, now we can see what it's doing basically. It's creating a cross tab that we see in the Excel a lot. So the Elena species, inside the Elena species, we have just one male. And if we look into this human species, we have 26 males. So there is no female from that species. And also from that here, zebra, there are just 2 male species from the zebra. And also we can look at the dataset to confirm. So if you want to look at the dataset, let's go to the species. Species is here, somewhere here. So let's click on this filter function here, species zebra, and we see there are only 2 observations and both are male, gender. Okay, so that's pretty much how we can do the tabulation. And also we can save these outputs. So we can already see that this is too big an output to look at in our console. So we can save it as a data frame and then look at that separately. So to do that, let's give it a name, cross tab, gender, species. And then what we need to do, so I'm using the data frame function. So the output that is producing is not in a data frame format. So I'm gonna use that, I'm gonna convert that type into a data frame. So what the data frame does, basically, it gives us this nice tabular format, which we can easily see using our visual panes. So when I run that code, I can now look at the data set. And immediately we can see the variable 1, variable 2, and frequency. So the Elena female. So what it has done, it has actually changed the data format too. So it has changed the data form from white. We see that there are 5 columns, and now it has 3 columns. So it has changed the data format so that it's easier for plotting. So what it's doing in the variable 2, it has combined all these columns here and then put them under one column. And also you can change the names of the variables here so that it's nicer and you can use it for plotting if you want to in your dataset. Okay, so the last one we're going to look at is, so now we know how we can look at a tabular crosstab. Let's say we want to look at the percentage rather than the absolute numbers. So how do we do that? So to do that, what we can do is basically we can pipe it to prop table. So what the prop table does, it takes rather than showing you the numbers, it shows you the percentage. Let's run this code and see what it's actually doing. So right now we can see that here, if you look at Elena, had just 1 male, but now we see a fraction. So what it's doing is taking the entire data set and showing what is the percentage of 1 Elena male in that data set. And then if you look at the human, and we can see human had total 29 or some males, and we can see it has the percentage is like 33%. Also the female, it has a percentage. So human, now we can see there's a female participant there. So if we want to look back, so human has actually 9 female Star Wars characters, which is total like 11% in our total data set. Okay, so that's pretty much it. And we can also look at, so that percentage may not actually make much sense because it's taking the number and it's taking the entire data set number and then calculating the percentage. So to change that, we can say, okay, let's calculate the percentage based on the rows, or let's calculate the percentage based on columns. So if you want to look at, let's say, what is the percentage of human, let's say we are interested in to know that what is the percentage of human female only within human. So that could be one thing. So here we can mention that, so margin, let's say margin 1. So it's going to consider only the row-wise values of the total and then calculate the sum, calculate the percentage. So now we can see the human male population represents 75%, about like 74%, and female, they present about 26%. And also if you want to look at, okay, human, in human population, the human female, what is the percentage of human female among all the female species? So then we need to change it to 2, which means column in this context. So here now, if you look at that, human, female, they represent 56% among all the female species. So that's pretty much it and how you can do that. Also, you can save this tabular format data as a data frame and look into that and use that as your different kinds of purposes like plotting data and everything. So that's all from this tutorial. Hope you all enjoyed the tutorial, and I'll also put a link of the previous tutorial in the description box. If you want, you can go back and take a look at the tutorial again so that you know the very basic functions that you can use to look at a dataset in R. Thank you all. See you all in the next tutorial. Bye-bye.